Continue. We got quite a bit to cover now. All right. Here we go again. Continue the stuff. We'll talk a little bit about the components, some kind of the type of sources we have, some of the systems configurations now. Main component in a system, in a solar system, is what? The array itself. Okay. Typically, you have individual modules. You hook them together in electrically or parallel methods, and you get a certain type of an output out of the actual array. Typically, we're producing what? DC power. Okay. Remember, and we're going to talk about this over and over again. And we're producing DC power. It has no frequency on it. Okay, so we have current and voltage, no frequency, and we can feed them directly into what? Into our loads, or we can utilize the DC power to charge batteries, or we can put in inverters. We change the DC into AC, and we can provide this power to AC loads, or actually we feed it back to the utility company, to the grid. Okay. Typical representation of how those things are, and how those things are actually mounted. And this is actually your modules. You put several of those modules together. You have an array, and typically what you're going to get out of them, you interconnect them, and then you get a certain type of voltage with a certain type of current. Voltage times current gives you what? Power. Power up here that you get is DC power. And power is measured in what? Watts. Okay? The biggest problem that that we have with any kind of system is to make sure that what the system that we put meeting what? The expected demand that we have, okay? And what happens is the demand that we have can fluctuate over a period of time whenever we're using a period, and most of the times we don't know the fluctuations. Sometimes we try to anticipate this one based on statistical data, but we don't know really how the energy is being used. So at certain times, we'll be able to generate that power and use it. Sometimes we generate that power, but we have what? We don't use it, and at this particular time, what do we do with it? Okay? So one of the options is either we store it, or we dump it out, we don't use it, or we use it for supplying some non-essential type of systems. So we have to figure out whenever we do any kind of a system like this, how to match it to our needs. You can have 5 kW system, use 1 kW, what are you going to do with it? In standalone systems, obviously what we have to do is do something with it, otherwise we lose it. If utility interactive system, we can sell it back to the utility. And the reason for that is if we look at typical PV system up here, here's what I have. If we look it up here, we see the actual demand over certain periods of time in a typical household might be different because we're using what? Some of the power in the morning. Typically nobody's home during the day, so the only power that's going to be used is what? Refrigerators and so forth, and all of a sudden at night we have different kind of utilization because we come back home, we're going to use all our power and so forth. Some of the PV systems require battery backup in order to be able to store them. Usually a battery bank is a group of batteries. You connect them together in series of parallels, and you'll be able to store some particular amount of power up there. Again, you need spacing for that. You charge it by the array and discharge it by the loads. So typical battery bank up here, and there's a whole section of the code deals with what? With the battery interconnections and where you store those batteries. There's a whole section on the book actually in here that deals with the type of batteries. Typically the types of batteries that you have and that you're using for storage is very similar to the ones you use in a forklift machine. The book does a real good explanation as far as explaining the type of batteries and how they work and so forth. If we have some time, we'll talk about it in greater detail for them. Okay. Then we have other types of storage devices. We call them flywheel energy systems. And What it is, I don't know if some of you have ever seen them, but typically it spins up the flywheel, it stores up the energy when we need it, it stores it up, we can get them out of it. One of the other approaches that we use is actually a capacitor. Capacitor is nothing more than two parallel plates with a certain amount of what? Dielectric between them, insulating material. You charge them, they have the tendency to do what? Charge and release what? Electrical energy. Very similarly that you have what? A coil. A coil charges what? A coil is used to what? To store and release what? Magnetic energy. So this is what capacitor. In the older times, they used to use capacitors to do what? To what is the correct power factor, but they used to use capacitors to be able to what? To retain data in the computers. Before we had batteries, and we used to retain data in the computer, we used to charge a capacitor, computer goes down in the power, utilize the power of the actually discharge the capacitor, so the computer can do all this backup savings very fastly to do that. The unfortunate thing about capacitors, to store a lot of energy, you need what? Huge capacitors. So usually capacitors they measure is called what? Farads. Most of the times you guys are familiar with something like microfarads, tiny little capacitors. You see, for example, the capacitors that they're using what? In motors? You see the little bulky thing in the top of the motor? Yes? That's a capacitor. Usually you use that for what? For starting the motor and also improving the power factor associated with that. Well, that is measured, physically measured in microfarads, which is what? Millions of farads. Typically, to charge a capacitor, you need voltage as well as space. Okay? A lot of space. So usually 1 farad capacitor is usually the size of what? Of your desk. So to charge a certain amount of power, so you're going to need probably a capacitor of what? The size of this room. Well, the other option is to make something which they call them supercapacitors, which actually can charge and store a lot of that energy into a small amount of space. Although a little bit expensive, again, it's a feasible thing to do. Okay. Now, what are some of the benefits with it? Because they don't have the problems associated with what? With batteries. Okay. Now, the other types of equipment that you have in the systems like that, obviously, you have power conditioning system. The reason we do that, or sometimes you refer as the whole system like that as an inverter, because it has all these capabilities. Typically, an inverter, what does it do? It changes what? DC to AC, and AC has to have what? Voltage, current, as well as what? A frequency, and it does all the cleanups to make sure that it matches the utility company's, frequency. So it does a lot of the interfacing between the utility as well as that. Okay. What else? Usually they characterize the power source, the power rating. They have a certain amount of power rating, input and output voltages, the type of waveform. There are different manufacturing techniques that they make in inverters. Different inverters, we'll talk about them. What are some of the manufacturing? Pulse width modulation. It's one of the types that we're using. They use for power quality and the power conversion efficiency. How much power really that from the input to the inverter to the output to the inverter, really do they have any loss? How efficient they are? 90%, 95%? Because the rest of them becomes what? Wasted energy. It takes us a long time to generate that power up there. Now all of a sudden, because of the inefficiency of the inverter, we're losing a lot of it. So a lot of the inverters, a lot of effort is being in the inverters, so the inverters become what? Very efficient. I think the efficiency of the inverters now, we have some guy here, it's probably over 95%. So they really put a lot of effort. Some of the initial, which is probably one of the most critical pieces of equipment in your whole system. If not the most critical, because if the inverter doesn't work, what happens? Well, you get DC, because you can get the array up there and you just plug your light bulb up there and you have light at least. Yes, sir?